So here we have a bolt that is undergoing a combined shear and tensile stress. Now what that means is our bolt, it's being stretched and at the same time it's being cut across. Now this force with the green arrow, that's going to be perpendicular to the cross-section area of our bolt in order to get that direct stress. And of course this next force with the purple arrow is going to be cutting across our bolt in order to get that shear stress. Now we have that 7 kilonewtons that's acting as a load, and that's the tensile load there. And what we have to do in order to find the shear and the direct stress is to find the component of that 7 kilonewtons. And what that will look like, if we were to think of this as a triangle, and if I'm to just close that side there to create a triangle, then that side that I've just drawn, that horizontal side, that will be representing our hypotenuse. And where the direct and the shear force combine or meet, then right there, that's where we'll end up having a 90 degrees. So it means then that our 7 kilonewtons, that will be our hypotenuse. And what we have to do is to find those unknown forces using the angles that we have, which is 50 degrees in that bottom right corner. So what the components will look like then. So for our direct stress, then that will be 7 kilonewtons, so 7 times 10 to the power of 3, and sin 50 degrees. So that will give us our direct stress, and that will turn out to be somewhere 5734 kilonewtons. So that's representing our direct stress there. And in terms of our shear stress now, it's going to be similar. So 7 times 10 to the power of 3, and that's cos 50, and that's going to give us 4015 newtons. So that will be the forces that we have, and then what we need to do is to just find the different stresses. So for the stresses, let's start with the direct stress. So direct stress is simply the force divided by the area. We can see what the diameter of the bolt is, so what that will look like. So that's just going to be our perpendicular force, which is that 5734 component, and divided by the area of the bolt. So I'm just going to use pi multiplied by the radius squared in this instance, and that will be 0.006 squared, 50.7 megapascals. So that's representing our direct stress. And then now we will need to find our shear stress. So for our shear stress, then that's same formula. So stress for shear stress there is our force divided by area once again, but the force that we will use is that 4115, and same formula for area. So that's just pi times 0.006 squared, and that gives us 35.5 megapascals. And if you'd like to support the channel, then please subscribe for more videos like this and give the video a thumbs up, and I'll see you in the next one.